And we're here. All right, ladies and gentlemen, Pascal's triangle. Right on top right there, I'm going to put a 1. You know what I'm feeling for the next row? 1 and 1. Next row, let's go. A 1 and a 1, but in the middle. Yeah, I like it. On the ends, I'm going to go 1 and 1. There is a pattern here. I'm not telling it to you. It's because I think you guys can figure it out. 3 and 3. Next row, on the ends, 1 and 1. Right there, a 4. Right there, a 4. Right there, a 6. Let me just see a show of hands. I'm not picking on anyone right now. I just want to see a show of hands. How many of us think we see the pattern? 1, 2. Okay. I'm going to go one more. 1 and 1 on the. Have we at least figured out that the ends are 1s? Okay. I bet you can guess what's going to go in these two spots. 5 and 5. It is going to be 10 and 10. All right. So Coco, if you've got it figured out, why is this one right here 10?
Because you're adding the 4 and 6 together.
You are. If you look above it, see how there's a 4 and a 6? You add those together, and that gives you 10. 4 and 6, add them together. That gives you 10. Can you guys see that in Pascal's triangle, every number is the sum of the two numbers sitting above it? So now let's finish the last two rows. It always starts with a 1 on the ends. Right here, 1 plus 5 would give us 6. 1 plus 5 would give us 6. 5 plus 10 would give us 15. 5 plus 10 would give us 15. Are we seeing that there is symmetry? That in Pascal's triangle, like over here and over here, they are identical. They are mirror images of each other. What number is going to go in the middle right there, everybody? Good. All right. So last one's going to go 1, 1, 7, 7, 21, 21, 35, 35. Okay? So this is going to be pretty useful to us today, and it's going to be useful for you to know what row we are talking about. So one thing you need to keep in mind is that the row on top, we're going to call that row 0. And the next one's going to be row 1. And now you'll see why we call the first one 0. See how the one with the 2 in it now is 2, and the one with the 3 in it is row 3, and the one with the 4 in it is row 4, and 5, and 6, and 7. So the row number is always equal to like the second number in the row. We good up to there? Okay, so that's Pascal's triangle. It would be good if you were able to generate a few rows of Pascal's triangle on your own. But I am going to tell you that your calculator will do some of it for you. So check this out. Let's pick a random number in here. Let's go to this one right here. Everybody circle that 21. I can get the calculator to tell me that 21 goes right here. And here's how I'm going to do it. We're in the 7th row, right? Give me a right. Okay. So there's this operation. It goes 7th row, choose. There's like a little C that you're going to see in the calculator. And then what you want to say is that, see this one right here? This is term 0. This is term 1. So it starts in 0 in this direction too. Term 0, term 1, and then this will be term 2. So in your calculator, turn it on. Good luck, sir. You pitching today?
Probably.
And then what you're going to do is you're going to hit the math button. Once again, the math button. And you're going to cruise over to prob. Prob is for probability. This is actually used in probability a lot, but we're not doing any probability with it today. You'll see where it says NCR. You're going to click on that, and then you're going to input 7 and 2. Just like I'm doing right now. And then you're going to hit the enter button, and sure enough, there's your 21. What did yours do? May I borrow yours for a second? If you have the old operating system, if yours didn't work, look up here. It's probably because you have the old operating system. What you're going to do is you're going to type in 7. So you're going to put the first number first. And then you're going to hit math and go to probability. Choose NCR. So you'll see 7 NCR and then 2. And now it works. Okay? Anyone besides Evan who's using my calculator who has the old operating system? Okay, a couple of us. You guys good?
Yeah.
All right. Let's do one more just to make sure we've got it. See that 15 right there. Everyone circle that 15. If you wanted to make that 15 happen in the calculator, you would say, what row are we in? So 6, and then choose, and then what number is it in the 6th row? 0, 1, 2, 3, 4. And keep in mind, if you're feeling lazy, you can always just move the cursor up, copy it, and then change the 2 numbers. So 6, choose 4 is 15. Ooh, magic. Questions for the good of the group? Pascal's triangle.
How did you get the 4 from 64?
I said this is term number 0, 1, 2, 3, 4.
Or
You can also count backwards. Look up here. See how this is the 6th row?
Yeah.
That means this has to be the 6th term. So 6, 5, 4, 3, 2, 1, 0.
oh, I got it.
Okay? So they always start with 0. They always end with whatever number this is. Okay? Now, I'm going to do something that is going to appear like it is completely different. Flip the page. This is the real goal for today. I want to give you a binomial to a power, and I want you to tell me what it is equal to. So, yeah, a plus b raised to the 0 power is 1. I agree with that. You guys can write a 1 down right there. Easy peasy. And then a plus b to the first power would just be a plus b. So those are the 2 kind of automatic ones. Let's look at the next one. A plus b to the 2nd power. Let's expand that. That's like saying a plus b is multiplied by a plus b, isn't it? Those are the same thing. So if we were going to multiply that out, we would go, let's see, a times a squared. Hey, I spent a few years in Ann Arbor when I was in college. Really annoying people will refer to Ann Arbor as a squared.
Why?
2 A's.
Because it's 2 A's. Ann Arbor, a squared. Yes, it should really be called Ann times Arbor. All right, so we got that. B times b is b squared. And then here we would have a times b and b times a. So we put those together, an ab and another ab, that would be 2ab. Okay. Now, here's the connection. Maybe some of you see it already. 1, 1 and 1. 1, 2, 1.
How is it 1 if it's a square?
Because it's 1 times a squared. All right, so can you guys see that the coefficients are just Pascal's triangle? So here's how you're going to do these problems. If you come to the 3rd row, or to the 3rd power like we have right here, you're going to say, what does the 3rd row of Pascal's triangle look like? 1, right? And then what are the next coefficients? 3. And then 3. And then 1. Now you'll notice that I'm leaving 2 spaces after each one of the coefficients, after the 1, the 3, and the 1. And the reason for that is that we're going to fill them with A's and B's. Okay, so everyone got this done? Here's where you're going to go next. You're going to say, all right, see how when this was to the second power right here, it started with A squared? When you're to the third power, you're going to start with A cubed. And I'm going back to the second one again. See how it goes A squared, and then A to the first power, and then A to the 0 power. Not having an A is like saying A to the 0 power, isn't it? So from here to here to here, from term to term to term, what is happening to the power on A? It is going down by 1. That's exactly what we're going to do here. We're going to say this is A squared, A to the first power, A to the 0 power. B is going to work in reverse. So if you come back right here, B is going to go to the 0 power, and then up, and up, and up. Okay, so this is a really quick way to expand these binomials. You okay? I wasn't sure if you were in pain or practicing shadow boxing. It was number 2. Okay. Coco.
Are we gonna have a break like in between the lesson and the
Yeah.
when there's a break, can we go outside for a while?
It's kind of hard to get outside. You have to go through the swimming pool.
So
They told me to stop taking kids through the swimming pool.
They
It's
won't
like a
know.
2-minute walk from here to the double doors.
Oh, no. That takes forever.
It's like a maybe 1 minute.
That's like, that might as well be on another continent over there. Where were we? Oh, we were right here. I want you guys to notice one more thing. Add the exponents together. What do you get? You get 3. Add the exponents together. What do you get? Oh, those are 3. Add those exponents together. What do you get, everybody? And then right here, add those exponents together. You get, and the original degree was 3. Okay, so we're going to do one more. This one is the 4th power. So you're going to start with 1. Let's see, what does the 4th row looks like? It is 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and 1. So I know it's kind of weird, but I want you to start your problems like that. Okay, and then degrees. Let's go degrees. This is going to go A to the 4th this time. 3rd, 2nd, 1st, 0. And then for the B's, just switch it. So B to the 0, B to the 1, B to the 2, B to the 3, B to the 4. Oh, Klein, I see it. This time, if you look at any term, what do 2 exponents add up to? Yeah. So that's a nice way to kind of keep yourself organized, that you know what the exponents are always going to add up to, and you know what the coefficients are because you know Pascal's triangle. That's the game for today, ladies and gentlemen. What kind of questions do you have?
Is this basically what we're learning this lesson?
Yeah, we're just practicing with this.
Oh, okay.
How you feeling about it?
How is this related to the rest of the
You're adding things.
mixed math? That's what they're saying.
Sort of like a series. I can show you the real connection, but I don't think you want to see it right now. Yes, sir.
He's a guy who found this.
The guy who found this is probably crazy. I don't know. I mean, mathematicians, kind of eccentric people. I don't know if crazy is the right word, though.
What was the point of coming up with this triangle? Like, what's the use for it?
Oh, what's the purpose of it? Well, the triangle is really important in statistics. It's really important in probability. It has like a lot of applications to it. What was that?
Can you use examples?
Yeah, I am going to play the lottery every week this year, 52 times. And the odds of winning the lottery are, I don't know, let's say 1 in 10.
Okay.
And in order to come out even, I have to win at least 4 times. What's the likelihood that's going to happen? you use this to work it out.
Sure.
Because we're not in a statistics class, like showing you how would be a little complicated right now. But that's one of the uses. All right, ladies and gentlemen, flip to the next page. This is what I want you to actually be able to do. I want you to look at something like this and be able to expand it. So step number 1 is going to look like this. Tell me what A is, tell me what B is, and tell me what N is. I'm going to start calling on you guys a little bit as we go through this. So Josh, would you get me going? What's A, what's B, what's N?
Oh, A is 2.
Yeah? No. Help him out, gang. What's A? It is 2x. Okay. B?
5.
Yep. And N.
3.
Beautiful. So you start there. That's step number 1. Step number 2 is you want to expand this out. So you start by looking at what is the third row of Pascal's triangle. Nick, I'm coming your way. What is the third row of Pascal's triangle?
1, 3, 3, 1.
So 1, 3, 3, and 1.
What?
Okay. Next step I'm going to do with you. You want A to be to the third power, to the second power, to the first, and then to the 0 power. And since A is 2x, that means it's all of 2x that goes in those parentheses. Go to B. B I'm not going to bother putting in parentheses, and that's because see how it has only one component? This has the 2 and the x, but this is just a 5. So I'm going to go 5 to the 0, 5 to the 1, 5 to the 2, and 5 to the 3. Okay, so that's step number 2, is you get it expanded out. Yes, Coco?
So is our goal just to expand it as far as possible, or just to expand it?
To expand it and then to simplify it. So let's go over your third step. Your third step is going to be to simplify these things. Now, folks, what is 5 to the 0 power? Okay, so that's not going to do anything. But this right here says 2x is multiplied by 2x is multiplied by 2x. So notice that the power is affecting both the 2 and the x. So 2 times 2 times 2 is going to give us 8, right? 2 times 2 times 2 is 8. And then x times x times x is x raised to the third power. The next one, when you expand it out, it looks like this. 3 times 2x times 2x times 5. So the calculation you need to do is 2 times 2 is 4, times 5 is 20, times 3 is, so this would be 60x squared. Third one is going to go 3 times 2x, and then I got a pair of 5s multiplied here. So let's see. 5 times 5 is 25. 3 times 2 is 6. 25 times 6. If I have 25 quarters, I have $1.50 x plus last one. Anything with the 0 power is 1, so that term's not going to affect you. 5 to the third power, what's that equal to? So there's your expanded form right there. Okay, questions on the first one? Moving to number 2. Start with A and B and N. Ilana, I'm coming your way. Could you tell us what is A? What is B? What is N? Okay, good catch. Did everyone see that she said this is plus a negative? So that's -1. Okay. Okay. Cool. So we start there. Now it's expanding time. Ethan, I'm coming your way. The degree is 4, so we need the fourth row of Pascal's triangle. What does that look like?
1, 4, 6, 4,
1, 4, 6, 4, 1. Okay. I like it. Fourth power, third power, second power, first power, 0 power. And then plug in our x to the third. Next space, let's take those negative ones. I'm going to put these in parentheses too. So negative 1 to the 0, negative 1 to the 1, negative 1 to the 2, negative 1 to the third, and negative 1 to the fourth. All right, let's start cleaning this bad boy up. I'm starting with the first one right here. I've got x to the third to the fourth power. What do you do with the exponents when there's like power outside, power inside? Yeah, so this is like saying what's x to the third times 4, so that's going to be x raised to the 12th, okay? Now I've got a negative 1 to the 0. We know that's always equal to 1. Keep going. Next one right here. I'm going to call on you guys as we're going through the terms. And let's go to Jacob on this one. Jacob, what's our second term going to be?
This is x to the power of 9.
X to the power of 9. I agree with the exponent. What about the coefficient here?
Times by 4.
Okay. And then what about the negative 1 to the first power?
Just stays the same.
Okay.
Times by 4, so just negative 4.
Okay. So that'll be minus. That looks good. All right, let's keep rolling. We're going to the next one. Ray, this one's yours.
Would it be 6x to 6? 6 power?
Okay, and then do we want it to be positive or negative? Yep, that looks good. I like it. Let's move to the next one right here. Simon, I'm coming to you.
It'll be at x to the third times negative 1 times 4, so it'll be negative 4x to the third.
Can you guys see what's happening with the signs? Positive, negative, negative. What are they doing? Yeah, they're we call that oscillating. They're bouncing back and forth. So the last one's going to be positive, and this one I believe is just equal to 1. So that's our second example. We have one more, but before we move on, any questions on this one? Okay, last example. Come on down here. This one looks a little different, doesn't it? So I guess the first thing is, can you locate the part of this problem right here that's related to what we're doing today? Yeah, it's that piece right there. So I'm going to be quiet for about 45 seconds here. Totally ignore the minus x cubed. Totally ignore the h. I just want you to expand the x plus h to the third power. Do that on your own right now. So I wrote the expanded version right here, folks. Check your work. Make sure you're on the ball. Questions? Anything we're wondering about? We good? Are we good? Are we good? Okay, so I'm going to assume we're all good on that. Let's go back to here. Put your pencil right there. Don't pick up your phone. Put your pencil right there. Don't pick up your phone. Put your pencil right there. You want to subtract an x to the third off the end and then divide by h. If you're wondering to yourself, what is this nonsense that I'm looking at right now? This is actually a pretty important equation in calculus, and I know a number of you are taking calculus next year, so we're doing this so that we can go preview next year. Hey, is there anything we can do to simplify? Nick, say something.
You just subtract the x cubed,
Yeah, so those two terms are gone.
and then you can divide everything by
Yeah, so that would be the first thing you do. And then when you divide everything by h, do you guys see that all three of these terms have an h to give? So that means this, 3x squared h is getting divided by h. And then 3xh squared, yeah, you get divided by h too. And then don't leave me out, don't leave me out. H to the third also gets divided by h. Well, what are we left with? First one? Plus h squared. Okay. Well, yeah, I'm just letting the calculus people know that next year they'll see how this connects to rates of change. All right, so that's the game, ladies and gentlemen. In a little bit, we're going to come back and we're going to have a lightning round. But right now, I think this is a good place for us to take a break. So stand up, stretch your legs, relax for a few minutes. Once again, when we come back, it's going to be time for the lightning round.
Mr. Klein,
Yes.
which